They embarked on a mission to set up a laser test in a frozen lake Nasijarvi, a 32-kilometer-long lake, north to the city of Tampere. A team, with high hopes in succeeding together, grouped up in a nearby cafe for final planning. The stars began shining. The moon showed its face. It was a clear night, providing perfect conditions to see distant lights, even with the bustling city's light pollution in the background. The team was well equipped for the coming adventure. They would set up a telescope to the southern end of the lake, near the cafe. The team scattered into 3 squads. One squad remained in the south to operate the telescope, binoculars and cameras, for observing and recording the event. The 2 remaining squads were equipped with lasers, one with red, and the other one with purple. The red squad, or a lonely commando, shall I say, traveled to an empty lodging area to set up the red laser. The purple squad traveled to a beach where they could mount a snowmobile and travel on ice to the north, to their final destination. The laser squads would set up the lasers and aim at the beach in the south where the telescope squad was positioned. The distance between the red squad and the telescope squad was 10.4 kilometers, or 6.47 miles. The distance from south to the purple squad was a whopping 23.1 kilometers, or 14.4 miles. As the lake was frozen over, the telescope could be set on ice, just beyond the boulders in the shoreline. The telescope was Skywatcher SkyMax 102, with a bracket for smartphone for recording. The telescope was firmly set up to 88 centimeters from the ice. A large white sheet was also set up to the beach to see if it catches any of the coming light, if the laser beam could be targeted. As the purple squad was still reaching for their destination, the red squad was ready and the laser was set up for a test shot. The test would be shot at 118 centimeters above ice. The red laser was highly inferior to the purple one in power output, less than 1 watt. Still, the team was confident the beam would travel the distance effortlessly. The telescope squad was ready with their equipment. The beam was clearly seen to the left of the amber light which was coming from a small lighthouse in near distance. The test from this height was a success. It showed even grander light when observed with a telescope. While the purple squad focused on getting their gear set up in the north, the red laser was again tested by setting it just above the ice. This time, the pointer was sitting on top of a glove, 3 centimeters above ice level, and pointed towards the observers. The continuous beam was shot and aimed at the observers, and as the tripod of the telescope can be seen on the right, it shows that the observers were looking at the target near the surface of the ice. The beam was again perfectly seen and recorded with a telescope. Now all hope lied in the purple squad in getting their gear set up perfectly and set the laser beam to travel horizontally all the way to the observers. The power output of the laser was 1.6 watts, providing strong, easily visible beam. Finding levelness was the first issue, and the aim had to be corrected many times through trial and error. The perfect aiming was proven to be even more difficult, as a single movement in any direction could move the beams several hundred meters in the opposite shore. Thanks to the city lights and a visible beam, the direction could be fine-tuned when looked through binoculars. Then, when everything was ready, they fired it. The laser was first set 45 centimeters above the ice level, to bypass the possible unevenness in the surface of the ice. Now the observers had a chance to witness something unique, something that would be imprinted into them, and what they could carry for the rest of their lives. These are shots through the telescope. The bright beam was seen perfectly, and even with a naked eye it was even brighter than the red laser, which was only a half the distance away. After the first shot, the laser was then set to 1 centimeter, and finally to 29 centimeters. All beams were seen from the opposite shore. The operation was a success. To maximize the results even more, the red laser was reactivated to get the both beams to the same recording. This would be yet another proof that the light beams from the opposite sides of the light spectrum, the red one being roughly 660 nanometers, and the purple one 405 nanometers, could both travel effortlessly to their destination without too much scattering.